Okay, this is lesson 6.1, graphing exponential functions. So I'm going to start with the second one first. An exponential function looks like this. It gets really, really close to a line, and then it increases or decreases very, very quickly. So let's look at our equation. This is the generic equation. We've seen this with lines. We've seen it with quadratics. With a line, it's y equals mx plus b. With a quadratic, it was y equals x squared. So this one has the exponent, that is the variable x. That's how you know that it's an exponential. X is the exponent. Some examples that you can have, it has to have a base. The base will not be an exponent. It can have the base multiplied by something. It can have the base with something added to the exponent. So we know this is not an example because this would be a quadratic. And we know this one is not an example because this one would be linear. We've already looked at the graphs of these. These are not examples because this one is a quadratic and this one is linear. And then looking at the tables. If you have a table, you're looking for things that change by a constant amount for x, which is just like you have when you're talking about an exponent or a quadratic, or if you're talking about a line. But what's different is that the y changes by multiplication or division. So if you look at this one goes up 1 every time, which is what we want, changing by a constant amount. This side, from 1/2 to 1, is times 2. From 1 to 2 is times 2. And from 2 to 4 is times 2. Same thing if you look at the next one. This is going up by 1 every time. This one, from 3 to 1, you are dividing by 3, which is also multiplying by 1/3, dividing by 3, and dividing by 3. These aren't examples of this. This one adds 2 each time. So let's look. You can't base it on the x because the x is still going up by 1 each time. This one is plus 2, plus 2, plus 2. We know when we add the same amount, this is linear. This one goes up by 1 every time on the x, but this is minus 1, this is plus 1, this is plus 8. So something weird's happening with that one. We'll learn what kind of an equation that is later. Let's look down here. We have 2 different types of exponentials. We have exponential growth. This is the one where it starts really close to the line, doesn't touch the line, but starts really close to the line. And it increases really, really quickly. Exponential decay is where it starts, where it has been increased quickly, and then it decreases quickly, getting closer and closer and closer to that line, but never touching the line. To graph these, we usually use a table. Now, I always start with -1, 0, and 1. And you're going to take 1/3 to the negative first power in your calculator, and you should get 3. You'll take 1/3 to the 0 power in your calculator. Anything to the 0 power is 1. And then 1/3 to the first power, which is 1/3. So let's graph what we have here. At -1, it's 3. At 0, it's 1. And at 1, it's 1/3. Well, what happens if I go to 2? That's going to be 1/3 to the second power. Which is 1/9. So at 2, it's at 1/9, which is even closer and closer and closer to the line. Let's draw this in. And then describe it as exponential growth or exponential decay. Well, according to our picture over here, this would be decay. We'll do some more practicing with this in class, and then we can do the practice problems.